So we are going to talk about industrial automations systems today. So what is this industrial automation system? So why do we need industrial automation, or why do we need automation? So from the beginning, okay, there were different types of control schemas, different types of controls, and all type of control required some kind of human interference in between. So to enhance this experience, to enhance this experience, we bought in some electronic based automation systems into our automation systems. So by default, when we talk about automation systems, you can say it's not just using PLC, or just using maybe an embedded system, a circuit board for automation, but rather than it is a group of objects. You can say maybe PLCs, HMIs, VFDs, no, lot of systems, not only just a PLC. So we will see what all these things do in the automation system, as well as what it is capable of. At the same time, we will also discuss about the different automation systems available. Not only on the industrial side, we have automation on different levels. We'll also talk about those different levels of automations as well. Right? Yeah. So let me just go to the next slide. Okay. Simply put, you can say what is automation. So automation means self-dictated, you can say. So there's a controller or a computer, you can say. This computer which can do whatever you want with respect to the coding that you're given. So you design a system with a particular set of rules, and you make that system run in that rule. So for example, you make a machine, you do the programming, and if the machine is not working as per your specification, or as per it is not running as per you like, it means the machine is not at fault. It means the programmer or the automation engineer who designed the system did something wrong. We have to accept that. Sometimes, sure, there will be some issues on the programmer side. I know, maybe if the programmer did not understand the requirement correctly, then he might, yeah, sure, make mistakes in the programming, and the machine may not work, you can say, as per his requirement. But in all other cases, if the machine is not running, it will be a programmer's fault in understanding the system, right? So the main advantage of using an automation system will be higher productivity. So by making a system automated, you will get more production. So it does not, the machine does not want to stop. It does not need breaks unless until it needs maintenance. So the productivity will be increased. So when a human does the job, maybe 50 products per day, the machine may do 100 or 200 or 300 per day. Similarly, superior quality of the end product. So superior quality in the sense, when we do a machine, or when we use a machine for automation or production, the end product will be similar. So for example, you take a carpenter who makes a chair, a wooden chair. So the possibility or the probability of two chairs that the same carpenter makes is not 100%. Will never be 100%. There will be at least a 1% of difference from both of these chairs. Maybe a small difference in the measurement, a small difference in the height, maybe a height, but it will not be identical in any case. But if it is made by an automated system, a machine, then you can say this system will be 100% identical. If there is a fault in the first chair, again, the second chair also will have the same fault. So that is what I'm trying to say. So this is automation. Okay. The third and most important the advantage is it's efficient usage of energy and raw materials. So when you do it in a planned manner, in a an exact manner, the machines will not make a mistake in most cases. So there will be no wastage or less wastage. So it will be efficient usage of energy and raw materials, which will save money, as well as will have a great impact on the environment. Finally, improving safety. In many industries, considering oil and gas, chemical industries, process industries, uh, smelting, foundry, all these kind of industries, there is a probability, there is a possibility that humans or the people who are working there is, you know, getting more, dangers there. Maybe high temperature, some chemical environment, breathing chemical gases, all these things. So places where humans are subjected to dangerous or harsh environments, machines can do it. So very less, with very less human interaction, a machine can do it. So I want to emphasize one thing in automation, that okay, let's make everything automated. So what will humans do? So don't we all lose our jobs? Yes, but not necessarily. So the jobs will change. Instead of a person who does, supervision, he will be now becoming a machine operator, or he will become a SCADA operator. So uh, even everything is becoming automated, the need for human intervention will be there, because ultimately it is a machine. It needs servicing, it needs programming, it needs, a lot of touch ups as it is running. uh, a human will be the one who will be entering the parameters of the output product. The parameters depends upon the quality of the output products as well. So it is not just the machine, but a lot of human intervention. So in this era, we can say the biggest impact here will be like the change of skill set of each of the, the labor chain. So everyone is now upgrading to becoming more factory friendly, automation friendly, machine friendly. Right? Hope you understood. Next, give me a second. Yes. Let's skip this. Okay, so now when we ask automation, so where is automation? So where you can see automation systems, you can say automation is now everywhere. So it's apt to say that from agriculture to space, because when you say agriculture, you can say this is the least automated system. Most of the in agriculture, many of the things are done by humans or manual. Even though there are machines to get the finest output, if you want the organic food, you want to do it manual. So agriculture is one of the least automated system, and space automation, or rocket science is one of the most advanced automation systems. So you can see automation everywhere now, from agriculture to space. Some of the major industry where automation is used is power generation, water treatment, oil and gas sectors, automobile industry, paper mills, everywhere. So I can guarantee you that in a day, consider you are waking up in the morning until you go to sleep in the evening or at night, you will use an automated system, or you will use a product of an automated system every minute of your day. For example, you wake up in the morning, you take a bath, it might be coming from an automated water treatment plant. You have your food, okay, you have bread, it is coming from an automated bakery. You travel on a car to from point A to point B to your workplace. The petrol, the diesel, the fuel is coming from an automated factory. The car that you are driving is coming from an automated factory. So when you are standing in the signal on the traffic signal, the lights are automated. So you can say every few minutes you will use something automated, something that is a product of an automated system. Even the dress that we are wearing, maybe the stitching is done by humans, but the primary material, the cloth, is actually manufactured in an automated machine. So automation is everywhere. It is omnipresent. That's how I call it, and it will never go away. It will never go away, right? Again, guys, please feel free to jump in or raise hands if you have any doubts. Yeah. Okay. So based on the automation sectors, there are four different categories of automation in this current scenario. The first system will be office automation. The second is home automation. Third is building automation. Finally, we'll talk about industrial automation. So industrial automation is it is the manufacturing end, so that we can call it the back end, because the common people will not see what is happening in the industry. They will be just using the products of the industry, right? So we will talk about all these three and four things, and finally we'll come to the industrial automation part. right? So what is the office automation? So office automation is nothing but your internet, your computers, your printers, video intercoms, audio intercoms, video conferencing, uh, all these kind of soft automation. These are called as soft automation. So nowadays there are even systems which can automatically, you can say, uh, you know do data logging, do works automatically. You have a biometric fingerprint for your attendance. Um, you go to your office and there is a printer. You just enter your credentials to make prints. You can call anyone in the office using a intercom. You can have a video conferencing system in your premises. Everything comes under office automation. All kind of ELV systems. That is also called as extra low voltage systems will come under office automation. So majority of the ELV systems comes under office automation, including even security and surveillance systems as well. Right. Next, the second type of automation will be the home automation. So this home automation is a booming sector. You can say a very highly booming sector in the Middle East, all over the world, not only Middle East. Europe is on a different level on home automation systems. So it means controlling your lights, controlling your AC, controlling your blinds, controlling your windows, curtains automatically. You place a sensor outside which will measure the light intensity, which will measure the pressure, which will measure the temperature, the humidity, and accordingly adjust the settings inside your home. So for this, one of the most commonly used technology is KNX. There is DALI. Uh, there is also some brands called as Kasambi, Control 4, Crestron, Laxon. These are all some brands, some technologies that they use for home automation systems. Home automation system also covers a wide range of aspects from safety, security, and automation. So you'll also have some kind of burglar alarm systems, surveillance systems like CCTV, and also video conferencing for video door phones, as well as automation for lights, ACs, and similar devices. Right. So the third automation system is the building automation system, or also called as building management systems. So this is another crucial part that is in the Middle East. So a building automation system or building management system is a combination of safety, security, surveillance, control, and optimization. So you can say there will be CCTV, which is the surveillance. There will be access control, which is security. There is fire alarm systems, which is safety. There is HVAC systems for comfortability. There is other systems like we can say burglar alarms, sun protection, uh, many more in the building. So building automation also uses technologies like KNX and certain other systems as well. Right. So this building automation or BMS, building management systems or building automation systems, are more prevalent in the Middle East. You can see all big buildings, all high-rise buildings, which has a centralized AC using these systems for their automation needs. Right. This is also a type of automation which covers the components that we use for industrial automation. So in this, apart from home automation and office of automation, building automation and industrial automation systems will use the same devices. So you can see, PLCs, you can see VFDs, you can see HMIs, you can see SCADA systems together here, or for both purposes, both for building automation as well as building management systems. Right? Any doubts till this, guys? Any doubts or anything that you want me to clarify till this? Anyone? No. Okay. Right. Then we can go to the next topic, that is our main topic, that is industrial automation systems. Okay, let me just quickly run through it. So industrial automation is nothing but the automation that is applied to the industry, nothing else. It's very simple and straightforward. You can say it is the use of advanced systems techniques to control instruments or machineries or process, reducing the need for human intervention. So an industrial automation system is a system which controls machinery, specifically any type of machinery, manufacturing, production, packing, disinfection, cleaning, any type of machinery. Now you can see automated machineries in every single field of the world, right? Yes. Let me just quickly jump to the next slide. Okay. So what are the objectives again? So we talked about the advantages. Now let's talk about the objectives. So there are five primary objectives. You can say first is improving the quality, as I said in the beginning, increasing the rate of production, increasing efficiency, increasing safety, and one of the most important aspect is reducing downtime. So what is reducing downtime? So there are two types of downtime when we talk about maintenance. There is something called as a planned downtime and an unplanned downtime. So planned downtime means we are stopping the machine or shutting down the machine for some kind of planned maintenance. Unplanned means the machine just breaks down. You forget to maintain the machine. It is running till it's in a breaking point and something breaks and the machine stops. So how automation can reduce downtime? So, okay. Um, in many of my experience, in many cases, when I'm going to sites for automation troubleshooting, it will be like this. So a machine breaks down, the mechanical guys will come. They say it's the electrical guy's problem. So the electrical guy will come. He'll check everything and he'll say it is the automation guy's problem. Then the PLC programmer will come and he'll say again, no, 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 this is not our problem. The mechanical guy's problem. So this will just go on in a circle. So what this PLC does? So if there is any issue on the electrical side, that is on the automation side, we can diagnose it. If it is a sensor fault, if it is an overload, if it is anything regarding to the automation system that we are installing or programming, we will be able to troubleshoot it, we will be able to diagnose it, and we will be able to fix it within a matter of minutes. But if it is in the older days where there was no automation, it will take a few days to find out the problem. Then you have to order the spare, it has to come. Then you have to replace it for another 2 days. So consider a factory that is, making millions per day. You stop the machine for 2 days, you lose a few millions in revenue, as well as, lot of cost for maintenance as well. So installing an automation system will drastically reduce your, you can say, your runtime cost, your maintenance cost, as well as increase the revenue in a very big manner. Yes. Next. So normally speaking, there are four types of automation. We call as manual, hardwired, electronic, and programmable. Let's quickly go through it. Okay. This was the first type of automation. It's still being used. I think everyone can relate to this. So there is a process and you want to control it, you just put an operator there or a person who can do that. You ask a person to switch on the motor. When the tank gets full, you switch off the motor. The problem is now it is less efficient, it's very slow. You will only know the tank is empty after water is not coming on the tap. But next came hardwired control. So hardwired control is one of the best automation in my perspective. Even though we are in the era of electronic automation, hardware control is one of my favorites. I have seen very large machines, robots, conveyors, automated conveyors, hydraulic presses, you can say turning machines, lathes, milling machines just running on relay without any kind of automation, like any kind of, not automation, any kind of electronic controlling equipment. So this is one of the best type of automation, which can outlive any kind of digital automation system. You can say a PLC or any kind of electronic automation system has a lifetime. Maybe a few years, maybe around 20 years or 25 years, 30 years. I have seen a few machines from Siemens, a few machines from Allen Bradley running for 25 years, 25 years, 28 years, 30 years, 32 years without any problem. But anyways, after a few years, maybe after a few more years, these devices will surely will be need to be replaced. But there are machines in Saudi. I have seen there are machines in Saudi. Many oil and gas plants, many oil and gas fields. They have still running relay panels that was installed in 1960. So it's approximately, you can say, again 60 years. Say 1963. Now it's 2023. It's around 60 years, and still the system is running like it ran in 1963. But yeah, it is less efficient, it is slow, but it serves the purpose. It serves the purpose. But we are trying to change this. See, you can see here how messy it is. If there's a fault, if there's any problem in this system, it is very difficult to troubleshoot. It will be very difficult to understand what it is doing. And if you want to do any minor changes, you have to remove all the wires and you have to rewire from the beginning, which is a headache. So we are now going away from this technology. We are already away from this technology, and we are mostly doing retrofitting for these kind of technologies nowadays. Right, right. Next is the electronic control, you can say. So electronic control means using of embedded controllers. Okay, many of you might be, coming from, some factories, or you're working on some kind of automation systems or anything. In those cases, you would have seen some kind of circuit board, not a PLC, not a branded controller. You would have seen some machineries. Majorly, you can see textile machineries, processing equipment, which was running on just PCBs, maybe manufactured from China or manufactured from the US, something like that. These kind of electronic control was more prevalent in the 1980s, 19, late 1960s, 70s, and early 1980s. But the problem is these kind of devices, once gets faulted, it is very difficult to troubleshoot. It is very difficult to replace. Maybe the company who manufactured that board might not be there now. Again, we are now changing these systems into newer systems like maybe PLCs, PAC systems. Yes, right. The major problem of these electronic control is these controls are not designed for the industrial environment. The temperature, the heat, the humidity, the environmental condition in an industry is much different than a computer. So if you remember, most of you guys might have seen uh, older computers, which needs a AC room. I have seen, computers which was only running on AC rooms because it was so costly. It needs to have a very clean environment. Similarly, these electronic devices also needs a very clean environment to run. It is not much suitable for the industrial environment. After a particular temperature, maybe like the temperature that we are experiencing in the Middle East, maybe 45 degrees Celsius, 50 degrees Celsius, 52 degrees Celsius, these devices will surely get faulted, not immediately, but eventually. Maybe it may work for one day, it may work for 1 year, but it is not as reliable. It can an electronic component that is working today can just fail tomorrow. There is a very, very big possibility for, right? Yes. So the next technology that we usually use is that, let's go to the PLC one. So I want to finish it a bit early in 10 more minutes. So is there anything, guys, any doubts, anything if you want to, clarify? I'm happy to clarify if you have anything. Thank you. Okay, let's talk about programmable logic controllers. So PLC is an electronic system. Again, I just said a few minutes, 2 minutes back, electronic systems are not suited for industrial environment. Again, I'm saying a PLC is an electronic device. Yeah, it is an electronic device, but an electronic device that is designed to work on an industrial setting. To work on an industrial setting. So these devices are specifically designed, programmed, and uh, manufactured in a way so that it can withstand all these environmental conditions. Okay, that's the main advantage of using a PLC. So it is basically a microcontroller or a electronic controller, but with an industrial grade component. With an industrial grade component. So PLCs was introduced in the late 1960s, and nowadays it's a different case now. We have everything now running on PLCs or any type of electronic control. Yes. Normally, there are 4 stages in an automation system, if you can see here. So normally you can see uh, there are 4 stages. The first stage is the, you can say, the field level, that is the transmitters and the actuators that is placed on the site. So a pressure transmitter, a flow transmitter, you can say a temperature transmitter, any kind of sensors. And similarly, outputs like pumps, motors, actuators, pneumatic valves, pistons, motor operated valves, control valves, all these kind of inputs and output devices consist of the transmitters on the field. Second, we have the RTU, that is the remote terminal unit. Normally, remote terminal units are used for long distance communication. So consider if you are having a very big plant and the distance from the transmitters or the sensors to the control panel is very long. Then we go for something called as an RTU. If it is it is just maybe a few meters, few hundred meters long, we can go for remote IOs. But if you are talking about very long distance communication, maybe I have a pumping station 50 km away from my plant, then I want to get the data from that pumping station to my plant, then we go for RTU systems. Then we have the control hardware. The control hardware could be a PLC, could be an electronic control, could be a PC. There are different types of technology now. And finally, we have a SCADA software, that is a supervisory control and data acquisition system, which is used to oversee the systems, which is used to oversee the system, right? Yes. Let's talk about this. So again, uh, the three levels, that is the field level, that is the sensors and actuators. Then we had the control level, that is the PLCs or any type of controllers. Then finally, we had the SCADA level, that is supervisory control. Finally, there were two more levels, that is the MES level and the ERP level. So MES, or the planning level, is, you can say, the control room level, maybe the control room level. And finally, the ERP level, you can say ERP means enterprise resource planning. So what it does, okay, let me give you an example for this. So you go to, you are maybe you are planning to buy a car. Okay, maybe you are going to buy a Toyota RAV4, for example, and you want it plain in lemon yellow, lime yellow, or very fluorescent yellow. So which is the color that is not available in the market. So what you do, you go to the Toyota website, you go to their pre-booking location, you go there, you select your car, you select your color, you are customizing the color car to be a specific color, and you are customizing your engine options, you are customizing your interiors, everything. Then you are doing your payment, and you are clicking buy. So now what happens? Whatever you are entering is on the ERP level. So as soon as you enter on the ERP level, the data then gets transferred to the MES level. There is a manufacturing level. So in the MES level, the MES systems will have direct control to the factory. So as soon as you give order, okay, I need a lime yellow Toyota RAV4, this ERP sends the data to the MES, which will then splits the data into the factory, sends the data into the factory. So even without any kind of human interaction or human intervention, an order placed by you on your computer will get to become a car. Maybe after a few days, as the MES accepts it, it will put it into the queue. So when your particular car goes into the paint shop, it will just get painted to green color, or sorry, lime yellow color. It gets all your customizations, your seat colors, your interior colors, any kind of customizations you have set up on your choices. And finally, a lime yellow color comes out of the factory. So this is done automatically. Even though there are people who is assembling these cars, they will get data from this automated system. So this is how a product life cycle, how a product works from the ERP level, from the ordering level to the production level works. So all this is now automated. All this is now automated. All right. Next. So some of the advantages of PLC, if you ask, it is very compact, highly reliable. Yeah, when I say highly reliable, it is highly reliable. I have seen Siemens PLCs, which was running for the past maybe 30 years, 33 years. The oldest one I have seen is around 40 years. It is an S5 system, which was installed in Nepal. There was one system in a brewery there. That was one of the oldest that I have seen. It is more flexible. You will be able to do many type of communication, integrate it with many kind of systems like PLCs, other PLCs, VFDs, HMIs, control panels, motor control panels, sensors, heart systems, many different devices. It has a faster response time, yeah, comparing to the hardwired system. It can do a lot of calculation immediately and instantly. Then finally, we have communication, as I said, communication capability with other devices. Again, easy troubleshooting is one of the biggest advantages of PLC systems. Okay, so let's quickly go to the next topic. So a PLC, you can say, is just one of the component for automation. So just programming the PLC and fitting it into your system will not make your machine automated. You need other components which will go, work with the PLC. So that is where we have other systems like, VFDs, that is where we have SCADAs, that is where we have HMIs, all these things. All right. So the PLCs are normally categorized based on their inputs and outputs. So there are both discrete outputs like sensors, like switches, limit switches, push buttons, uh, pressure switch, temperature switch, flow switch. These kind of in on-off sensors, as well as analog sensors like temperature transmitter, pressure transmitter, flow transmitter, radar transmitter, rotational sensors, uh, G-force sensors. There are many different types of analog sensors as well. So it means you can simply say discrete means on and off, analog means continuous. That is, you are able to control the fan speed from 0 to 100%, not in steps, but 0, 1, 2, 3, going on till 100. So this is analog system, right? When you say analog system, there are a lot of examples we can give in the industry. Yeah, again, we'll do that in our Q&A session, right? Yes. So normally analog inputs will range from 0 to 10 volt and current from 0 to 4 to 20 or 0 to 20 milliampere. There are many reasons for this to happen. So we will be also looking at this during our courses as well. Yeah, yes, let's go about. Yeah. So for programming a PLC, we need four things. You need four things. You need a PC with the software. Okay, you need a PC, the PLC software, a communication cable between the PLC and the PC, and you need a professional programmer. So this is where we and you come in. Becoming a programmer, looking at all the sequence of operations, the control schema, and creating the program such that the machine works in absolutely 100% efficiency. So it is the primary, work of the programmer to do the machine programming. Yes. So there are five different types of programming languages defined in IEC 61131 standard, that is the International Electoral Commission. Uh, so which defines how a PLC programming structure should be designed. So the most used programming language will be ladder diagram, which is a kind of pictorial or a diagram based programming structure. You can say more than 90% of the world's PLC programmers. Maybe if you have like if you have 100 PLC programmers, all the 100 will know ladder diagram. So that's how ladder diagram is famous. Then we have STL or structured text. This is a text-based programming language, like if some opcode like functions, which is most primarily used in ABB and Siemens. You can say maybe a few programmers, maybe out of that 100, you can say maybe five programmers to seven programmers may know this programming language. You can see these kind of programming in missionaries that is mostly imported from the European countries, specifically Germany, France, Italy, these kind of countries, where the primary OEM will be Siemens. So you can see whenever you have a Siemens machine that was supplied from Germany or any kind of European countries, you will get this programming language in the back. So that's standard. Next, we have instruction list. This is a long forgotten programming language. You can say we are not using it anymore. It is an opcode based programming. It's very rarely seen in programming, in PLC brands. One of the PLC brand in which I know IL exists is Delta and ABB. So Delta supports instruction list as well as ABB PLCs supports instruction list programming. Then there is something called a sequential function chart. This is a flowchart based programming, a type of programming that is mostly used in traffic light signals. Mostly used in traffic light signals programming. Then we have the FBD, which is a second most popular programming language, uh, which is again mostly used in Siemens, ABB, Schneider, Mitsubishi, and Allen Bradley systems. This is a block-based programming. Anyone who has a good understanding of a ladder programming language can also do FBD programming, right? So now there is another programming language that is newly introduced last year. It is called as CEM, also called as cause effect matrix, which is primarily supported in high-end Siemens PLCs. So that is what they are replacing STL with now. So cause effect matrix is mostly used on safety programming, and safety PLCs are SAS, safety integrated systems, as well as field safety systems, right? So in a programming, it's very simple. PLC programming is one of the, so ladder programming specifically is one of the most easiest programming language you can learn. Anyone who knows how to draw a circuit, okay, you know how to connect an input, a switch with a light, in the paper can do ladder diagram. It's that easy. It is very, very easy. You can see a primary structure of a program like this. So you can have a rung which has the inputs and outputs. So here you can see this is the rung here. This is the rung here. And rung means the line in the ladder diagram. So you can see there are two vertical lines and one horizontal line. These two vertical lines are called as power rails, and the center line is called as a rung. So the reason it is called as a ladder diagram is when you write large programs, you will just get steps like this. Okay, there is one line here, then again the line will continue, and there will be another line. So you can, after looking at the system, you can say that it is looking like a ladder. That is why we normally call this as a ladder diagram. Right? Next. Let me just finish it. Okay. So normally PLCs are selected based on these four criteria. The primary criteria is IO range. What is the number of inputs and outputs a PLC can support? The packaging and cost per points. Okay, so if you are buying a PLC with 8 input and 4 output, the cost will be less. If you are buying the same model PLC with 20 inputs and 8 outputs, the cost will be more. So we'll be we'll be also calculating the packaging and cost per point. Some brands, this packaging and cost per points will be very high, maybe double, triple of some other brand. You can say the most costliest brand will be Allen Bradley, Siemens, ABB. Cheapest brands will be Delta, Mitsubishi, this kind of Japanese PLCs or Chinese PLCs. But in the functionality wise, reliability wise, both are very good. Memory capacity is how much programming you can do on the PLC. Like, okay, how many lines of program? Basically, we call it as instructions or lines. A typical PLC can accept around 7,000 to 10,000 lines, even the basic PLCs. Higher end PLCs can support maybe a few 100,000 lines, maybe 1 million lines of code, or 2 or 3 million lines of codes. And there are some PLCs which also accepts programming, a memory card which can further enhance this memory capacity as well. Finally, we have something called a scan time. So scan time means the time required by the PLC or the hardware to sense the input and give the output. So as your PLC's size increases, or as your PLC's program size increases, the scan time will become higher. That means a typical PLC, the scan time should be around 0.1 milliseconds. That is, less than 1 by 10,000th of a second. Less than 1 by 10,000th of a second. So when a PLC scan time goes above 1 millisecond, it means it is getting slow. It means it is getting slow. So when you are going for a very large number of IOs, or when you are going for a very large number of programming, a big program, always go for higher end PLCs in which the scan time is very, very low. Like you can get it like 0.01, 0.02, 0.1, 0.2, something like that. So such that your system will not slow down as you go into the programming much. Yes. So based on IO range, you can say there are low end, smart relays. This is the basic PLC. Then we have low end PLCs. We have medium end, and we have very high end PLCs. So okay, the smart relay, you can say it can support up to 8 inputs and 4 outputs. Low end PLC, it can go up to 128 inputs and outputs. This medium end PLC particularly can support around 512 to 1024 inputs or outputs. The one at the bottom, the more high-end system, this can support around 8,000 IOs in the system, nearly 8,000 IOs in the system, not directly, but using distributed or remote IO systems. Next, based on the IO range, again, in Siemens, we have smart relays, low end, medium end, and high end systems. Like smart relays is logo, low end will be 1,200 and S7 200. Medium end will be S7 300 and 1,500, in which S7 300 is now absolute. Semantic manager from Siemens is also now absolute. So Siemens is now urging us to move into S7500 series along with the AA portal. And on the right side, you can see the S7400 system, which is the higher end PLC range in the Siemens system. Higher end PLC in the Siemens system. So you can say this is similar to Allen Bradley's PAC systems or compact logics, not compact logics, Allen Bradley's control logics systems. Right. Yeah, let's keep this. So again, one of the biggest advantage of having PLCs is having this redundancy configuration. Redundancy means having a backup PLC which is running side by side. We have both hot and cold redundancy. Hot redundancy means both PLCs will be running simultaneously, and if one fails, the other will automatically take over. It like the second PLC or the slave PLC is waiting for the primary PLC to fail or die. Whenever the first PLC fails, the second PLC or the standby PLC automatically takes over control and keeps the system running. These kind of systems are mostly used, or you can say, are widely used in critical process systems, where you cannot shut down the machine just immediately. There are many process industries in which you cannot just switch off the system, or you just press stop, the machine won't stop. I have worked with glass industries where it will take around 1 week to start up the machine and 1 week to stop the machine, because the raw materials once gets loaded into the machine will take a few days for the output to start coming out. So in those kind of critical operations, where the process is very critical, it is better to go for a redundancy configuration. So it will look something like this. Oh, you can see here there are two CPUs here, 2500 CPUs from Siemens running parallel. So this is a redundant system, and you can see the IO modules are distributed. You can see the IO modules are distributed here. So this system could be an example for a real-time redundancy configuration. Next, let's give this there. Okay, so these are some of the brands in which PLCs are available or widely used in the market all over the world. So Allen Bradley from US, Siemens from Germany, Schneider from France, Mitsubishi from Germany, ABB from Switzerland, GE is US, Delta is Taiwanese, Omron from Japan, and LS again from Europe, right? So these are some of the well-known PLC brands. It is not limited to these brands. There are hundreds of PLC brands, uh, many Chinese brands, many unnamed brands, many European brands, which are not listed here, but it is used everywhere in the world. But these are some of the example I just want to show you, because these are the most widely used PLC brands. Then we have the most important part, that is the SCADA system, that is supervisory control and data acquisition. So a SCADA system is nothing but a system which is used to monitor, on the supervisory side. Okay, on the supervisory side. So this system is usually the control room part of the system. So for small machines, it could be a HMI, but for big plants or big machines, it will be normally, you can say, what we a control room where the SCADA is just set up, right? Yes. So the main advantage of using a SCADA is, you can have a real life models of your plant inside the SCADA. You can monitor, you can control, you can give commands, you can give supervisory commands, if that's what I would recommend. Um, for complex machinery, SCADA can be used for direct control as well. Yes. Then we also have HMI system. So you can see these type of machineries everywhere. This type of touch screen interfaces are near to the machine. These are called as human machine interfaces, primarily used for single machine control. When we talk about SCADA, it is a multi-machine control. It is for the whole plant, where the plant will have like maybe 20, 30 different types of machineries. But the HMI package here will be usually for one particular uh, PLC or one particular machine, right? Yes. Then we finally have the distributed control system. So the distributed control system, you can say, is the most higher end of all automation systems, mostly for process control industries, chemical industries, oil and gas industries, where a very large number of machineries, a large number of inputs, large number of outputs is required, and large number of redundancy is required. So normally, DCS cannot be used for a small application. It is normally used for the entire plant. So normally it will have three levels: the engineering station, where the programming and the configuration is done; the field control station, where supervisory commands can be given; and finally we have the human interface station, where the actual machine operation is done. So you can see here, the first is the engineering station, the automation software side. Then on every one of these plants, there will be a, you can say, a field control station or an FCS. And finally, we will have human interface station. So you can see in these images, if you can see, There are small screens in each of these machines. So that is the human interface stations. This is the human interface station, right? So this is what we do in automation. So an automation means it's not just PLC. We need to know how to do PLC, how to integrate it with SCADA, how to integrate it with HMI, how to integrate it with VFDs, which I have not explained in this PPT due to a lack of time. And the most higher end automation will be mostly on the distributed control system side, on the distributed control system side, right? So this is how you go into the industrial automation system. So first you need to learn PLC, then you need to learn the additional components required for PLC like HMI, like SCADA, like VFD, all these things. Then finally you will be learning about DCS on the end. So the DCS is, you can say, one of the most high-end system on the automation side. Yes. So, guys, we are ending, we are coming to the end of the webinar. I want you guys to have, if you have any doubts, yeah, Mr. Ahmed, yeah, I think you have a doubt. Can you type it on the chat, or you can unmute and ask me your question, Mr. Ahmed.
Hello, can you hear me? Hello? Hello, can you hear me?
Yes, Ahmed, we can hear you.
I can hear
Okay.
you. Yeah.
Engineer Dilton, I would like to ask a question regarding the RTU. There was a slide where you have mentioned the RTU. Can you
Yes.
please, if you don't mind, can you please re-explain the RTU to
Okay.
the
You want to know what is an RTU, how it works, right?
Yes, please.
Yeah, okay, sure. Let me just go to that slide. I'm happy to, clear it out. Okay, so RTU is nothing but remote terminal unit. Okay, so when we say RTU, it means the IOs or the system is distributed. The system or the IOs are distributed. Distributed in the sense, for example, you can see there's a control panel here. And in the control panel, there is a PLC. I think this is a Mitsubishi PLC. Yeah. So there are many IO modules on the side here. So, for example, you have a PLC which has, you have a system which has nearly maybe 500 inputs and 500 outputs. Okay. And this input and output is spanned across a very long distance. A very long distance. Okay. You have a part of your machine nearly 200, 300 meters away. Okay. Then the control panel is in your control room and the IOs are, very long distance away. So in this case, consider you want to wire, you have to bring wire for 100 inputs and 100 outputs from the field unit to your PLC. So what happens? You have to lay at least 300, 400 wires. So in that case, what we do, instead of laying this much number of wires, what we normally do is we'll put a remote IO unit, or also called as a distributed IO unit. Okay. So this distributed IOs, like shown in, okay, let me just show you the distributed IO as well. Um, Give me a second. The basic side. Yeah. So if you take a look at this slide, you can see here the inputs are separately, connected to the PLC. So this is the CPU and the inputs are separate. So this is called as a remote IO unit. So here the IOs are near the PLC or near to the CPU. You can also put this away at a distance as well. Okay, this is a remote IO system. That means if you are able to, if your system is nearby, maybe nearly, within a distance of your cables, for example, you can lay cables from your panel to these systems. But what if your distance is very high? As I was talking earlier, what if your distance is very high? You can say, okay, I have 20 different pumping stations, which is spanned across 20, 30 kilometers. And I have a central plant from which I have to monitor. There is no possible way we can lay cables to all these individual plants. So in this case, what we normally do is we will use RTUs or remote telemetry units or remote terminal units. This will have some kind of communication in it. It will have some kind of communication in it. Okay, it could be a radio communication like 101 protocol. It could be an internet-based communication. Nowadays, yeah, it's all internet. We just put a SIM card and we just send the data over internet through MQTT or telemetry transfer protocol. And on the central SCADA, this data will be received and the data will be exchanged between one of the other stations. This is RTU. RTU means remote terminal or remote telemetry units. So this is mostly used for very long distance, transmission. So in older days, before GSM and other kind of wireless systems were available, they were using RF. If you know about radio towers, right? Our AM and FM radios, they put radio towers every 20-30 kilometers, and they used to send data through these RF towers. But nowadays we don't need that. We are now using SIM cards for direct GSM communication. And even if you are very remotely available, okay, there is no internet connection, there is no mobile data network, then there is even satellite based communication nowadays available. So this is RTU, Mr. Ahmed. I hope your doubts got cleared.
Yeah, thank you so much. I also have two remaining questions if you
Yeah,
are if
sure.
allows. The even if it's wireless, it will not have any problem with delay, or the system will be built like they will have a CPU near there to process it and just transfer the data for viewing and supervisory with the RTU to the HMI or the SCADA office.
Okay. So you are worried about the delay, right? Okay.
Yeah.
Yeah, okay. I will give you the example for this. Okay, there are two types of remote telemetry units. Okay, one is with the CPU. Okay, as you are saying, we can have a local control there, and if you want to only view the data, this method will work. Okay, you'll have for that you don't need to have a RT unit at all. You can just have a PLC with a remote communication device enabled. That's more than enough. But when you are talking about pure RTOs, these will be usually used for remote switching where delay is not a problem. Okay, a few seconds of delay is not a problem. Okay, you have a pumping station and you want to know the flow. You want to switch on the pump. You want to switch off the pump. It does not matter if it is taking a few seconds. But
Uh,
if
yeah.
it is very real time, okay, if it is very real time and it is very process critical, there are systems nowadays which can send data within half a second or within 100 milliseconds as well. That's a different system. You need to spend more on the hardware as well as the software. But nowadays, even very fast communication between RTUs are also available, right? Yeah.
Okay. Thank you so much. Also, a question about the CEM, the new language for
Yeah.
programming the
Yeah.
you have mentioned that it's mentioned for safety. So that programming language is or the design of the language is structured for fail-safe CPU, I guess.
Yes, yes. Actually, you can see the CM only in Siemens as of now in TAA portal version 17 and above, not 17, yeah, from 17 and above. It is see the structure of the CM programming is more suitable for fail-safe operations. It's not suitable for our standard PLC programming. So Siemens has designed a programming language which is more suitable for fail-safe. You can say like that.
Okay. Thank you so much, Engineer Delton.
Yeah. Thank you, Mr. Yeah, thank you. Any other doubts, guys? Any doubts? Anything that you want to discuss? I'm happy to help you. We have a few more minutes. Maybe we'll take 5 more or 10 more minutes. Anything? Any doubts? You can ask any basic or advanced. Whatever I can help.
Engineer Delton?
Yes. Yes.
Regarding the mentioning the classes of the CPUs, you have mentioned the 1200 is like low end,
Yes.
and the S7 400 to be a high end.
Yes.
Is even the S7 400s like older version than the S7 1200? Uh, how
Okay.
can yeah
Okay, I
how
agree. I understood your doubt. Actually, you can see the thing is, the 1200, you can put it into perspective like this. The 1200 PLC by default, okay, on its CPU can only accept up to 128 IOs. So here we are talking about the range of PLCs based on the number of IOs it can primarily support. Okay, so you can say 1200 as a low end, but not in terms of functionality. In terms of IO range. So if you want more than 250 IOs, more than 300 IOs, better go for 1500. Okay, so in 1500 it also has some limitations. Okay, these many thousand IOs. So you can say the 1400 is for you can say much of distributed control. Okay, distributed control in the sense an S7 400 will not be a primary system. The S7 400 will work as a master alone. So under the S7 400, it has the communication capability, it has the processing capability to have multiple slaves under it. So you can have 10 or 20 S7 300s or S7 1500s or S7 1200s under it to do the processing. So this will act as a master processing unit. So it will have the S7 400s have a lot of communication capability, like 4-port Profibus PA, Profibus DP communication, Profinet with real-time communication, Profinet with fail-safe communication. And S7 400, you can say it's like a server system. Even though it is old, it is not like it's not just it's not, we cannot say it is not powerful. We can say the S7 400 is still getting revamped. I hope if you have gone through the Siemens's last hardware expo, they have also launched a system called as S7 4100. So which is maybe replacing S7 400 in the near future, but S7 400 is still a running model. S7 4100, they have mentioned it um, as purely for process control. It's not a DCS, but not a S7 400 as well. It's in between DCS and in between S7 400. And again, Siemens also has a PCS 7 system, which is the DCS of Siemens, which has all these systems as slaves. So there will be a PCS 7 server. Under that, there will be S7 400, S7 300, S7 1500, S7 1200. So even though the 1500 and 1200 is relatively new, it cannot compete with the S7 400 because the newer hardwares coming from Siemens for S7 400 is more powerful than 300 and sorry 1500 and 1200 as well. Yeah,
Okay, I understand it. Thank you so much, engineer.
thank you. Yes.